Hello. In the task 5 of MathSpace, I'm going to do a question from the end. It was question 16. Your numbers might be slightly different, but I'm sure the procedure will be the same. I've got to solve for m here. And they've said 10 minus 6m plus 2m squared equals m squared plus 8m plus 9. What is m? All right. The first thing I'm going to do is make this equation equal to 0. As we've been doing in class. All right. So 2m squared, I'm going to minus m squared from both sides to just be left with a single m squared. Right. Let's get rid of this 8m. So we can minus 8m. We've got to minus it from this side as well to maintain our equality. And then let's minus the 9 away, so we're left with 0. So I've got to do that both sides. 10 minus 9 is 1. Okay. I look at that and I think, could I factorize it? Could I use null factor law? If I factorize it, is this possible? M plus whatever. If I can do that, I can solve it easily. But I can't. Because I can't think product and sum, how do I get the 1 and the 14? No, don't go there. So what I'm going to do instead is use quadratic formula. We're going to say m equals minus b plus or minus square root b squared minus 4ac on 2a. In this instance, our a is a 1, our b is a minus 14, and our c is also a 1. Okay. So let's write that instead. M equals minus 14, positive 14, plus or minus the square root of minus 14 squared, which is 196. Minus 4, now this bit I always write out in full. I find this is where some mistakes can be made. And then I need to divide by 2a. In this case, that's just 2. 2 times 1 is 2. All right. What we've got in here is 196 minus 4. Okay. M equals 14 on 2 plus or minus 192 on 2. I've split up the fraction, but we could keep it as one fraction if you like. So 14 squared is 196. The 4ac was really easy for this quadratic because I was just timesing by 1 and 1. So I got 196 minus 4, which is 192, square root. Okay, we can still tidy this up. M equals 7. Now, in the 192, I think there's going to be some squared numbers hiding. If there is, I can pull them out of the square root. What I mean is, let's actually try. I'll get my calculator. Does 192 divide by a square number like 4? And you can see it does. It's 48. But in the 48, there's more squared numbers. There's a 16 times. Does the 192 divide by 16? Yeah, it does. 12. There's still a square number in the 12. Does 192 divide by 64? I know not to check the odd numbers. So why have I tested a 4, a 16 and a 64? Because they're squared numbers. Let me show you what I mean. Just considering this 192, I'll do it over here. The square root of 192, I could write the 192 as 3 times 64. Okay? The reason I want to do that is because 64 is a squared number that can be square rooted to equal 8. So instead of leaving it as square root of 192, I could say it's 8 square root 3. Right? And what I've just done is simplify the surd. Right? Surd, S-U-R-D, for square root. Right? Basically, I mean, we're going to look at surds later on in the year and talk about them a bit more. But I just thought I might as well show you how to simplify a surd. This 192, there is a square number hiding in it. The highest square number I could find was 64. So I can square root that and say, well, that was just an 8. And I was still left with the square root of 3. I could write it as a decimal maybe, but I'm not going to. It's more accurate just to leave it as square root 3, right? So we get plus or minus 8 times square root 3 divided by 2. Right? I've changed the 192 to 8 root 3. Okay? Don't need that anymore. One more bit of tidying. 8 divided 2. I can do that. That's 4. Right? So I've got two solutions for m. One of them is 7 plus 4 times the square root of 3. And the other solution, comma, is 7 minus 4 times the square root of 3. Okay? Done. I think MathSpace may, I'm not sure, but it may be picky. It may say you're only half right if you don't simplify that surd down.